Most computers we interact with, our smartphones, our laptops, are beautifully sealed black boxes. We consume what they display on the screen, but we are kept entirely separate from the complex machinery inside. The Raspberry Pi is the exact opposite. It is an exposed, palm-sized circuit board that functions as a fully capable computer. Conceived as a concept in 2006 and officially launched to the public in 2012, it was designed specifically to strip away the mystery of modern hardware. Its creators followed the tech industry tradition of naming hardware after fruit, adding Pi as a nod to the Python programming language it was built to run. With a price tag that can be as low as $5, it quickly became one of the best-selling computers globally, finding its way into classrooms and labs alike. By removing the expensive outer casing and exposing the raw components, the Pi makes the underlying architecture of a computer visible and accessible to anyone willing to plug it in. This diagram maps out the bare board into distinct geographic zones, which lets us understand exactly how it processes information. Right in the center is the brain of the operation, a quad-core processor sitting alongside up to 8 GB of RAM. Positioned nearby is the communications array, letting the brain talk wirelessly via Wi-Fi and Bluetooth. Along the edges are physical inputs and outputs, an Ethernet connection, 4 USB ports, an audio jack, micro HDMI, and a USB-C port for power. You can plug a standard keyboard, mouse, and monitor right into these perimeter ports and use the board exactly like a normal desktop PC. The physical layout separates complex computational power in the middle from familiar connection points around the outside, making the raw hardware highly accessible. If you flip the board completely over, you'll find what actually brings that hardware to life. Tucked underneath is a micro SD slot. In the Pi ecosystem, this tiny memory card acts as your permanent hard drive. You use a beginner-friendly installer to load a flavor of Linux, like Raspberry Pi OS, directly onto the card. Slipping that card into the slot and powering up the board wakes the sleeping hardware, giving you an operating system to start working in. Looking at this diagram of the board's top edge, we see the hardware that separates it from standard computers, the General Purpose Input-Output, or GPIO, header. These metal spikes act as dynamic pathways of data. Just below that sits a dedicated CSI connector, specifically designed for integrating custom camera hardware. The operating system underneath gives the board software intelligence, while these specialized pins provide the physical interface to wire up mechanical inventions. The true value of the Raspberry Pi is measured by what you attach to it in physical space. You can start simply by wiring external LED lights directly to those GPIO pins. A basic Python script tells the operating system to toggle the voltage on those specific pins, turning the code on your screen into physical light in the room. For more complex builds, the board's specialized ports handle the heavy lifting, like the CSI port capturing raw video data while the CPU manages real-time encoding. By utilizing pre-built software libraries to manage the network stream and the camera's hardware drivers, a beginner can assemble a wireless security system that would have previously required an engineering degree to design. This same logic scales up to power local web servers, autonomous robotics, and even large-scale industrial prototypes. By combining a cheap, capable processing brain with open physical connectors, the Raspberry Pi lowers the cost of experimentation, letting anyone with a $5 board and a USB cable begin building their own machines.